Hello everybody, this is Zareian Jahromi from Power Electrical Developing Advanced Research Group. In this short training video, I'm gonna talk about coordinated SSC-PSS control for damping power system oscillations. Actually, in this video, I wanna talk about how to set optimal coefficient values for SSC controller and PSS controller when they are coordinated with each other to reduce power system oscillations. Like the previous training video, let's go to the reference paper which is selected to talk about mathematical problem formulation for this problem. As you can see in this paper, that is named Time Delay Approach for PSS and SSC based coordinated controller design using hybrid PSO-GSA algorithm. Before I want to talk about simulation and implementation of this problem, like the previous training video, I'm gonna talk about mathematical problem formulation for these problems. As you can see here, the equation from number 1 to 6 discuss about modeling of generator. Also, fig number 3 show us the structure of PSS that is used for power system stabilizer in this formulation. As you can see, the coefficient factors of T1, T2, T3, or T4 that should be selected by the optimization process. Also, as you can see here, you can see the structure of SSC based damping controller to reduce the power system oscillations during the operation or during any disturbance to the system. So the main question is here, how we can select the parameters of T1 to T4, also TW, T1S and T2S as a coefficient factors of SSC to reduce the power system oscillations during the operation for different disturbance that may be happen to system. As you can see here, the Matlab Simulink model that is used for this scenario is shown in fig number 7. So you can see the structure of this simulation, and we need to simulate this case study in Matlab simulation and try to set the parameters T1 to T4 for SSC controller and parameters of power system stabilizer during of PSS controller for a generator that is used in this simulation. So let's go to the power system simulation and implementation of this study in Matlab Simulink. For example, as you can see here, we have this file that is used for power system optimization. If you open one of these simulation files that is used in different format of Matlab simulation, if you open here, you can see the Matlab simulation file based on the simulation that is used in this paper. This is a generator here. Also, you can see the controller. For example, this is a power system stabilizer based the structure of the power system stabilizer that is discussed in fig number 3. If you open it here, you can see different parameters of these parameters. For example, KP1, TW1, T1, T2, T31, T34. So as you can see here, all of these parameters are important parameters and coefficient factors of stabilizer based on the structure that is shown in the paper. Also, you can see this block by open it and look under mask here. So you can see the coefficient factors and transfer function that is used for power system stabilizer based a model of this model of the power system stabilizer that is discussed in the paper. So another transfer function that is used for controlling of the SSSC to control the power flow during of the transmission line, two parallel transmission line that is used for connect to bus number 1 to bus number 3. So the main question is here, how we can control the power flow through the transmission line that is connect with that they are connect between bus number 1 and bus 3, and how we can manage the control the voltage reference to control the power flow during of this transmission line and control the exciter voltage using the PSS to make the system stable and reduce damping oscillation of the system for different scenarios such as fault or such as the line outage during of the system. For example, in this scenario, we use the three-phase fault to make a disturbance to the power system. So how we can set this parameter in power system? As you can see here, we have a main file. If you open these parameters is set by PSO. As you can see, we have 18 parameters. Total parameters is 18 for SSC and PSS, and try to set this value. We set a parameters between minimum, lower bound, and upper bound of these values are defined here. Also, we use a objective function here. If you open the objective function, you can see the structure of the programming code for set the different parameters that is used in a Matlab simulation file. For x1, the parameters x1 to x18 is used for respectively kp, tw, t1, t3 to t42. So another notable tips that I want to talk about it is related to the set the parameters in simulation. The main question related to the implementation of the simulation and optimization is here. How we can optimize the parameters in Simulink using a Matlab programming code. So in this training video, you can see and you can learn how to set the parameters of the Simulink using a Matlab programming code. In this regard, you need to set the model properties, and you should use here and set the initial parameters as a global coefficient factor. You should specify all of these coefficient factors as a global coefficient factors, like the global coefficient factors that is used here. After that, you can see the name of the simulation. The simulation is run, and DW1 and DW2 that you can see here as an objective function. Yes, exactly, is here. DW1 and DW2 is used here. Here to define the objective function. By run this simulation using pressing the this key, the power system oscillation power system optimization is a start, and after the simulation is finished, you can see the best value for coefficient factors of SSC and PSS here. It's a time-consuming process because it needs different optimization process to complete it. Also, after the process is finished, you can set the parameters of the SSC and PSS to see output result of the system. In another func that I provide you, you can see the optimized simulation file where for fault scenario and line outage scenario. If you open the, for example, fault scenario, you can see the simulation result when a fault happened to system for this transmission line between second of 1.3 to 1.5. If you open the if you run the simulation and see the simulation result, you can see the affection of damping. For example, if you set this simulation, you can see the damping during of this process. Also, you can see the voltage at each pulse by pressing this value. If you zoom in, you can see the affection of coordinated controller that is used for damping the oscillations by the line outage during these time. Also, you can see the another scenario of fault in system. For example, if line outage is happen to system, a line outage is happen to system between second of 5.1 to 5.3, and we want to see the output result and action of the coordinated controller between SSC and PSS, and we want to see the result of this disturbance to system. If you open the and set this block, and if you zoom in simulation, you can see the performance of the controllers that is used in simulation. Hereby study the simulation for a line outage that is happened to system between second of 5.1 to 5.3, and as you can see here, the coordinated controllers can reduce the power system oscillations during of these line outage that happen to system. So you can set the parameters according to the another scenario, and you can see the also you can use this project and you can change all of these changing into system according to your desired model that you want to have any research, any study to these parameters for this system. In the next training video, I would like to talk about more details about this scenario of simulation and how to set the coefficient factors of a power system simulink using Matlab programming code. For more details, and if you want to download some of simulation that is done in this training video, you can go to our channel in Telegram using this address, and you can download all of the simulation that I have done in this power system channel, and you can use them into your study if you want to continue your research academically. Thanks for your attention. Take care. Bye for now.